Welcome back to lesson 4.4. Let's finish up these examples about using the first derivative test. We do have a process for this. Remember, for number 4, the first step is to check the domain. And when I'm looking at that function, I've got a negative x in front of this e to some sort of power. And I'm noting that, I can plug in anything here. I can plug in a positive number. I can plug in a negative number. I'm not exactly sure what the graph of this looks like, but I went ahead and I did graph it on Desmos. Highly recommend going ahead and graphing it as you're working through the problems in the homework. That way you know what to expect. This is what the graph looks like. I can see a high here at when x is negative half, and a low here when x is positive half. And it looks like it hovers around an n value there of 0. But since I'm not looking for an n value, I'm not worried about it. And I'll say that behavior does, like I said, look like I could plug in any old x value that I want, and that line will just get super duper close to 0. And let's take a look now after we do that. So we're saying that the domain is unrestricted. So I just want to take the derivative in order to find the critical numbers. And this is a product rule problem. Whoops, since it's a product rule problem, let me take negative x and take the derivative of it, and I get negative 1. And let me take e to the negative 2x squared and say that I'm going to get a derivative, and that will be a negative 2x squared as a power of e. Don't forget that chain rule hook-on piece. There is a function in there, and I want to take that derivative. So my derivative is going to be a negative 2 times a 2x. Remember, because the negative 2 was out in front, and then I'm taking the derivative of x squared, so I get a 2x. And so this really is then negative 4x times e to the negative 2x squared, okay? And I'll do this times that, and that will be my derivative. So f prime of x will end up being negative x times negative 4x times e to the negative 2x squared plus negative 1 times e to the negative 2x squared. Did I say that right? E to the negative 2x squared. So there's a lot of stuff going on in here. Let me just simplify it out. And so I have 4x squared e to the negative 2x squared minus e to the negative 2x squared. And you might be thinking to yourself, what could I do with this? This is quite the mess. But notice how I have this term in both expressions. And while there isn't a number in front, I can always create a number, 1 specifically. And that means that I could factor now. I could factor this piece out, and I have 4x squared minus 1, and it is going to be multiplied by e to the negative 2x squared. And that's still quite the beast to look at and think about. And I know some kids have a hard time with this kind of factoring piece here, but as we practice it, it'll get easier. When I'm looking at this, setting this equal to 0, I'm just going to tell you, I know that it never hits 0. E to any power will always give me some kind of number. Cannot equal 0. So I can't, no critical number here. So there's no critical number for me to be able to find. It's never going to hit 0, because even if I put e to the negative 1/2 power, that just drops it into the denominator, makes it, e to the 1/2 power, which is really 1 over the square root of e. I mean, that's a number. I can find that number. I mean, Desmos would tell me what that number is. It's the square root of 2 point whatever, e is. So here, though, that you should recognize. I'm really hoping that you do recognize it. And you might not, but this is 2x being squared times 1 being squared. That's a difference of squares. It's a pretty popular one. It's not one that I usually make you guys memorize, but if you recognize it, you'll see that we can factor it like this: 2x plus 1 times 2x minus 1. And then I want to set all of that equal to 0. So I have 2x minus 1 equals 0. I'm going to add 1 to both sides. I'm going to divide by 2. and I get x equals 1/2. And on this other side, I get the same thing, but, you know, the opposite, right? So I now have two critical numbers, okay? X is a half and x is a negative half. And I'm going to do my number line. And don't forget to label it. That's the most important point. I can't give you points if you don't label it. And I'm saying I've got negative 1/2 here and I've got positive 1/2 here. And if you don't like the number line, I don't blame you. Go ahead and do an f prime of x table where you put in the negative 1/2, you know you got 0. You plug in the positive 1/2, you know you got 0. And some kids really like this better because, you know, they can really see now where the numbers they should pick come in. So you pick these numbers. Remember, this is your choice, and I'm just picking easy numbers, right? And then I'm going to plug it into the original function, the whole thing, by the way, even with its pieces, right? So I'm going to plug it into there, and I am not interested at all whether or not I get an actual number out of these table. I just want to know, was it positive, was it negative? So if I do 4x is squared, that means that whatever pops out here is always going to be positive, which means that this is always going to be positive. Now I want to multiply it by e to the negative 2x squared. And again, I'm saying that I know that those values are always positive. E is not going to be turned into a negative because there's a negative power. Remember that fractions are created by powers. So a negative power will just create a fraction. So this is also going to be positive. So I have a positive times a positive, which gives me, hello, a positive. Yay. Okay, then I'm going to plug in 0, and I have 4 times 0 being squared, and that's when something different happens, okay? Because this all turns to 0, and now I have a negative in front of what will always be a positive, and so I have a negative times a positive, which gives me a negative. And then down here, I'm going to say that this is just a repeat. Oh, does that say -1? Sorry, it's supposed to say +1. So I'm going to square a positive, and I'm going to get out a number, but that number, I'm telling you, is definitely going to be a positive. And then I'll say that, you know, I had that e value, which is always going to be positive. And now I am all set to say that I will get a positive out of that. Now, just looking back, I noticed that I didn't finish right here, that I didn't finish thinking about that whole expression, and I apologize for that. So the whole expression was that -1 was going to be squared, multiply that by 4, and then take away 1. Well, I knew that that number is going to be bigger than 1. So it turns out, by the way, that this is -1 times -1 is 1, and 4 times 1 is 4. So this is 4 minus 1, which is a +3, which is why I said that would be positive. And I maybe didn't say that all out loud, but I wanted to make sure I said it now. Down here, I get the same thing. I get a +3 times that positive expression. Whatever e power I get, I will still have a positive number. So on my number line, I could say this is positive, I could say this is negative, and I could say this is positive. And this is the moment where the number line really is helpful, right? Because I have a positive slope, and then I have a negative slope, and then I have a positive slope again. And as soon as I visualize that, or by graphing it, by just like trying to draw a positive slope, trying to draw a negative slope, out pops the idea. All of a sudden, I realize that there is a relative max at x equals -1/2, and there is a relative min at x equals 1/2. Now, you might be a little bit worried about finding those y values, and I don't blame you if you had to. That would be stressful. But let me see, first of all, he asks for a lot of pieces here, right? He talks about the interval where it's increasing. Interval increasing. I will say that, remember, I'm down here at -infinity, so it's from, soft bracket here, sorry, -infinity, all the way up to that 1/2, which is negative, and it starts again up at 1/2, and it goes all the way over to here to positive infinity. So that's my increasing, and it is decreasing. And I'm going to call this the interval of f of x, is increasing from there to there. Oh, so it's decreasing, ready, from -1/2 up to 1/2. And again, this is that moment where he said in the book, it doesn't matter if you use open brackets or closed brackets here. All right, no worries. And then if I was trying to tell you the actual points, so if I want to evaluate my original function all the way back up here, if I wanted to find out what f of negative 1/2 is, it will be negative times, ready, negative 1/2, and then it'll be e to the negative 2, and here's my negative 1/2, which I am going to square. Ooh. All right, so then I end up with a negative times a negative is a positive 1/2, and there's my e, and there's my negative 2 times, well, negative 1/2 times negative 1/2 is going to be 1, and because a negative times a negative is positive. 2 times 2 is 4, so this is 1/4, and that's a power. So negative 2 times 1/4, a quarter of 2 is going to be a half. And it should be negative because that 2 is negative. So this is really the same thing as 1/2 times e to the negative 1/2, which is the same thing, which, you know what, you can just write that down. But if you were trying to look for a multiple choice answer, and you are looking to see, well, what is the y value? The y value would probably be written like this. Ready? 1/2 is times the square root of e. Okay, that's probably how it would be written. I'm questioning on whether or not they would rationalize it. If they did rationalize it, what would we get? We would have the square root of e on top, and we have 2e on the bottom. Yeah, I just don't know. I'm guessing they would leave it like that. I find it very unlikely that they would do that one at all. It just kind of looks weird. All right, so then I'm saying that if I wanted to write that point down, I would say it was negative 1/2, and ready? Like I said, if this is a free response, you could just leave it like that and be happy. Or if you were looking for a multiple choice, you would get this 1/2, and it is 1/2 times the square root of e. And then the other point where this guy is, and I'm sorry about my handwriting being so bad here. This point would be, ready, positive 1/2, and I end up getting a negative 1/2 e to the negative 1/2 out of that guy. All right. So that was example 4. And by the way, let me double check on this graph. What is 1/2 times e to the negative 1/2? Turns out it is 0.303 and negative 0.303, which I think is actually just a very pretty number. So I thought you would like to know what that decimal was. For the last example here, number 5, it says we've got what? A polynomial. We know we could plug in any x value we want. We have an unrestricted domain here. And when I look at the graph, I highly recommend on these homeworks, feel free, take a look at the graphs. There's the graph, and it's pretty, wow, look at that. Boy, that thing grows fast, doesn't it? And it doesn't really seem like it has much of a dip to it at all. I see something's going on, interesting right around here. In fact, I've got some concave downness. I've got some concave upness, but I'm really feeling like this is a lot like an x cubed. Oh yeah, that's right. Take a look over here. It is x cubed. Take away something, add a little something. Yeah, so I'm going to guess this one's strictly monotonic increasing. And what does that look like algebraically? So let's find the derivative. F prime of x equals, what's the derivative of x cubed? It's 3x squared. What's the derivative of x squared? It's going to be 2x, and that was being multiplied by negative 3 out in front. And what's the derivative of 3x? It's a 3. So let me simplify this. 3x squared minus 6x plus 3. And, ooh, that looks factorable. I'm going to take a 3 out of there. X squared minus 2x plus 1. Oh, well, there's your perfect square. I definitely made you memorize that. And so that's going to be what? X minus 1 quantity squared. Don't get confused here. I know this is the same thing as x minus 1 times x minus 1, but you don't need to set them both equal to 0. Just pick one of them and set it equal to 0. You're going to get the same answer on the other side. So I'm saying that is equal to 0. And so, 3 is equal to 0. Boom, I don't need that. That's not useful. So I'm not going to do that. But this x minus 1 equals 0. Add 1 to both sides, and I got x equals 1. So that is my only critical number that I have here. that I can find. And I'm wanted to do a number line, and we've done a bunch of these now. So I'm wondering, do you need the table? Because if you need the table, do the table. But I'm looking at it and I'm saying to myself, just take a look at this function right here. There's a positive number, and then there's this value. So this is always going to be a positive. And what's going to come out of here, I have to square it. Oh, it doesn't matter if it was negative. When I square it, it is going to be a positive. So I have a positive times a positive in that area. I have a positive times a positive in that area. I'm always going to get a positive number. So it is strictly increasing. And that means on this interval from negative infinity all the way up to here through positive infinity. So negative infinity all the way up to positive infinity. And so there is increasing always, decreasing, and sorry about my handwriting, never. All right. And that critical number that I found turns out to be, well, what that's called, this guy right here turns out to be, it's called a point of inflection. All right. And so when we move on to the next section, that's when we're going to cover that. Highly recommend you read this last little bit here. This is our critical, bit here. Function example 5 is strictly monotonic function. It is strictly increasing. They can do it strictly decreasing as well. This one didn't happen to be just decreasing. And it illustrates these two important points, that not every critical number produces a maximum or minimum, and that even though the slope at x equals 1 is 0, the function is still increasing. Now let's take a look at that. Right here, that's where that slope is 0. And I'm having a hard time highlighting it, but yeah, it's what, 1, 1? Yeah, I'm having a hard time highlighting it. There it is. That's where the slope is definitely 0, but it didn't make it be a maximum. It still isn't a maximum. It still just continues to increase after that slope is 0.